Have you ever looked up at the night sky and asked yourself, what is our place among the stars? Long before we had telescopes, our ancestors sat around fires looking up, asking that exact same question. Fire gave us warmth, protection, and an evolutionary edge, but above all, it gave us light. Throughout history, light has been the ultimate cheat code of the universe. It's the key that unlocked our reality, challenged our greatest geniuses, and forced us to abandon the idea that we are the center of everything. Today, we are going to explore how one single everyday phenomenon, light, shattered human ego, broke the laws of physics, and opened a window to the mega-universe. Fast forward to the era of Isaac Newton. Newton gave us the ironclad laws of mechanics. He turned the chaotic heavens into a predictable ticking clock. But there was a rebel in his perfect mechanical universe: light. Newton faced a massive, unsettling paradox. If the universe is truly infinite, static, and filled with an infinite, uniform distribution of stars, as Newton believed it must be to prevent gravity from collapsing everything into a single point, then a terrifying mathematical truth emerges. Think about it. If you stand in a dense forest, no matter which direction you look, your line of sight eventually hits a tree trunk. In an infinite universe of stars, the same rule applies. Every single line of sight should eventually hit a star. The night sky shouldn't be dark at all. It should be blindingly bright as the surface of the sun. This is known as Olbers Paradox. The darkness we see is proof that something fundamental was wrong with our model of reality. To solve these revolutionary paradoxes, Newton had to rely on a divine creator. But light wasn't done yet. It was about to pull Newton off the throne of physics. Who could possibly dethrone Newton? Enter a 16-year-old teenager named Albert Einstein. Einstein asked himself a simple yet dangerous question. What would the universe look like if I rode a bicycle alongside a beam of light? At the time, James Clerk Maxwell had formulated giant equations proving that light is an electromagnetic wave. In the physics of Newton's time, speeds were relative. If you run next to a train at the same speed, the train looks still. So if teenage Albert rides alongside light, the light should look like it's frozen. But Maxwell's equations said absolutely not. Light never stops. These equations predicted a single absolute speed for light in a vacuum, no matter how fast the observer is moving. This directly contradicted Newtonian physics. Einstein, in a stroke of absolute genius, chose to trust light over Newton. The answer was hiding in plain sight. The speed of light, c, is constant. Einstein realized something mind-blowing. It doesn't matter how fast you move. Light will always run away from you at the exact same speed. But how is that mathematically possible? To keep the speed of light constant, Einstein realized the universe had to sacrifice something else. It had to bend time. Time is not a universal ticking clock that runs the same for everyone. It bends and slows for those moving fast. Einstein realized his childhood dream of riding a light beam was impossible because light will always outrun you. But in return, he gave us the theory of relativity.
But the story doesn't end there. Light pushed us even further into the bizarre world of quantum mechanics. It forced us to drop our prejudices about how reality works. In the realm of the ultra-small, the impossible became possible. Light is also the savior of structure. It's the outward pressure of light, radiation pressure, that fights against gravity, stopping giant stars from collapsing into themselves and turning into black holes. And perhaps most magically, light gave us a time machine.
Because light takes time to travel, about 8 minutes from the Sun, 4 years from the nearest star, and billions of years from distant galaxies. When we look through our optical telescopes, we aren't seeing the universe as it is today. We are looking into the deep past. We are seeing the childhood of the cosmos. Light showed us our true place. We live on a tiny rock, orbiting an average star in one galaxy out of billions and billions of others. When early humans looked up at the stars, hoping to find their special central place in the universe, they could never have imagined that the light hitting their eyes would destroy their ego, but give them the entire cosmos in return. Light is the ultimate key to existence. We have spent centuries decoding its language, yet we still don't know what it is, only how it behaves. Light remains our greatest tool and our deepest mystery. If you want to keep exploring the wonders of physics with me, hit that subscribe button, leave a like, and tell me in the comments, if you could travel at the speed of light, where in the universe would you go first, and what specific era would you want to visit? Thanks for watching and stay curious.